We would like to welcome you to the rollout of our new artificial lift technology, PhaseLift, one system for all phases. After fracturing operations are completed, the frac fluid is flowed back, and the well then produces oil, gas, and water until the critical velocity required for flow cannot be maintained, and the well loads up. At this point, the first artificial lift system is installed in the well. In PhaseLift, we use standard handling tools to install our patent-pending dual concentric tubing, which uses a proprietary manufacturing process to create the Ducon threads and couplings. Ducon uses time-synced threading so that the two pins and boxes are made up simultaneously by applying torque to the 3.5-inch tubing. The purpose for the Ducon connection is to create 3 separate conduits within the wellbore. With the ports in the ID of the coupling, the B area becomes the third full-length conduit. The 3 flow paths created can be utilized in a variety of combinations to optimize production from a well across the full spectrum of rates seen during a well's life cycle. Encapsulated Ducon side pocket gas lift mandrels are installed in the Ducon string, just like conventional gas lift systems, except without the use of a gas lift packer. With the Ducon string in the well and the wellhead equipment installed, the Ducon tubing can be used as a velocity string to extend the flowing period if the well is still capable of flow. Flow can go up the A and C areas or up the C or A areas separately, depending on the flow rates and critical velocities being observed. The 3 chambers of the Ducon string also provide a means to effectively treat the tubulars for corrosion, scale, or salting by continuous or batch treating methods. Because there is no packer in the well, a standard ecometer can be used to determine fluid levels in the casing and monitor producing bottom hole pressures. To reconfigure the well for the next phase, standard Slickline equipment is used to change out the side pocket gas lift valves to the desired configuration based on well performance and producing bottom hole pressures. The first valve changeout can be eliminated if live valves are run when the Ducon string is initially installed in the wellbore. This type of valve changeout takes place without the use of a rig and happens as the initial step before moving to each succeeding phase. Following the gas lift valve changeout, the second phase, annular lift, commences by injecting gas lift gas down the B area while producing the well up the C area. The well is brought on production by unloading the fluid in the annulus through the use of the installed gas lift stations until the lowest lift point is established. As before, a producing fluid level can be measured to help the operator maintain production at an optimized state. This periodic monitoring may indicate the need to convert to the next phase or simply make adjustments to gas lift volumes required. Phase 3 is conventional gas lift, where, following a gas lift valve changeout, gas lift gas is injected into the B area while producing up the A area. Again, the well is unloaded using the gas lift stations installed until the lowest lift point is established. The Ducon encapsulated gas lift mandrels utilize gas lift valves with 3 sets of seals to match up with multiple ports in the side pocket. This design flexibility to redirect flow allows for a single mandrel to serve the needs of each phase in a well's life. With frequent fluid level surveys and Slickline intervention, adjusting to changing conditions is both data-driven and cost-effective. Phase 4 is the gas submersible pump phase, or GSP phase, and is the major differentiating attribute of the PhaseLift system, allowing for continuous chamber lift. The GSP phase can support production rates from 50 to 800 BFPD without a packer, so the reservoir only sees the hydrostatic head of a standing fluid level in the C casing area. If the end of the Ducon is installed at or into the lateral, the realized abandonment pressures will be even lower than rod pump. The chamber is created by installing upper and lower standing valves into selective X nipples towards the bottom of the Ducon tubing string. PhaseLift has a patent-pending pump-down solution that allows for Slickline to be used in horizontal wells. The GSP cycle begins with fluids in the A and B areas of the chamber between the standing valves. Lift gas flows through the GSP control valve into the B chamber area, displacing fluid into the A chamber area up and through the upper standing valve. The GSP control valve continuously allows lift gas to be injected into the A area above the upper standing valve to keep previous fluid lows moving to the surface. Once the chamber is purged, the GSP control valve then vents both the A and B areas of the chamber into the C area, enabling the chamber to be refilled for the next cycle. The GSP can cycle in the way 10 to 12 times per hour and maintain a near continuous flow stream above the upper standing valve. Phase 5 is the final phase and is designed to transition to intermittent lift operations. The upper standing valve will be removed as part of this phase. PhaseLift is also compatible with the use of plungers to improve efficiency and to further lower the ultimate abandonment pressure for your wells. As you've seen, PhaseLift allows you to operate during the high-rate period with annular lift out to the end of the life of your well, delivering lower abandonment pressures, lower lift costs, lower economic limits, higher margins, and ultimately delivering higher EURs.